Exponential, huh? I thought she was going to say something. Exponential equation applications. Dang, y'all, we've taken a lot of notes already this year. I'm going to need a second notebook. All right, let's just review first. Anytime I put the word recall, that means like remember. This is something you should remember. All right, what does the equation of an exponential function look like? What is the parent equation? Y equals, you were right, she said A. What comes next? Parentheses, you are right. Don't say it like you're guessing. What comes next? Good. Raise to the, there we go. I'm hoping we remember that. X is the exponent because it's exponential. We remember this, right? Okay. So I'm hoping we remember if an exponential function is growing, the B should be, they're all positive. Good. If it's growth, B is greater than 1. If it's decay, what? It's less than 1, but it has to be, what'd you just say? Not less than 0. There we go. It has to be bigger than 0, but less than 1. Now, if you're like, I don't remember that, that's not good because I wrote this down with you last week. This isn't something you have to remember from Math 3. We did this when we did exponential functions. We wrote down where B couldn't be 0. It also couldn't be 1. I even showed you why it couldn't be 1. What happens when B is 1? Good, it's a constant because 1 to anything is just 1. So you're just going to do this number times 1 every single time and get the same thing, okay? All right, did anyone ever show you why B bigger than 1 is growing? You know I gotta show you why this stuff works because I hate y'all memorizing crap because then you never remember it. And I think that's what you did in the past. Kendall, pick a B that's bigger than 1. 2? Sure. 1, 2. We'll just do that. She said 2, so I'm going to do 4, 8, 16. I'm going to do one more. All right. Not necessarily. I could have stretched it. So in this case, this one has a stretch of 2. Yep. So the base, does everybody agree, is multiplying by 2 each time? That is my B. That is my factor. I'm multiplying by 2 every single time. When we multiply by 2, what do you guys notice is happening to our numbers? They're getting bigger, which means they are, ding, ding, ding. Pick a number less than 1, somebody, but bigger than 0. 1/2 sounds good. If it's 1, it'll be a constant. 1, 2, 3, 4. All right, if we multiply by a number smaller than 1, what's happening to my numbers? They're getting smaller, which means it's decreasing, decaying, okay? So you should be able to look at an exponential function, see the factor, and be like, oh, that's growing or that's getting smaller. Sound good? All right, so this is the part I'm hoping you remember from Math 3. To find growth, if you know the B is bigger than 1, you should not have to do what I'm about to show you. Did everybody hear me say that? If they give you the factor, let's write that down actually. Write this down because I don't know that this was differentiated for you in the past. B is the factor. So what happens when you are given a rate? Who remembers from math 3? Happens when you're given a rate. Kevin. By that much each time, right? Very good. So look up here. When you are given a factor, that is the number you're multiplying by every single time. If you are given a rate, they're telling you how much it's increasing or decreasing at each interval. It's not what you're multiplying by. So who remembers how we find the factor for growth? Not minus if it's growing. Good. So y equals a times 1 plus r to the t, right? Or you could say to the x. X is always time in these. Who remembers how to find the factor when it's decay and we're given a rate? What do we do? There we go. 1 minus r to the x or the t. Just remember your independent variable for real life stuff is almost always time. Online people, do we remember this from math 3?
Yes, ma'am.
Okay, I'm going over it with you right now. Does it make sense? Okay, good. Then I'm doing my job. That's good. I can't change your past, but I can help you learn stuff. Okay, Cody? I got you. All right, so can I go ahead and just do an example? Listen to me very carefully. Listen to the things I say because I'm not going to waste our time by writing it down, okay? Grace, can I use you in my example? Okay. Grace will be driving soon. Grace is going to buy a car. Probably not Grace, probably her parents. But either way, she's getting a car, capiche? When she first buys the car, its value is $18,000. What happens to a car's value as time increases? Good, it goes down. So we already know this is a what kind of problem? Decay, beautiful. The car is, what did I say, $18,000? Okay, the decay rate each year decays by 18%. Set me up an equation. You can just write it. Set me up an equation. Try it. If you're writing in pen, you might want to wait. I think most of you are pencil people though, which is beautiful. The initial value was 18,000. It's going down by 18% each year. Set me up an equation. Oh, wait. Let him think. I'll call on you in a second. I thought you had a question. He was ready. That's good, Kevin. We like that.
You said 18%?
Uh-huh. I guess I was feeling the number 18 this morning.
Did you see how much it was?
18,000. I just want you to set up the equation. If I want you to solve, then yes, I will give you an amount of years, okay? Each year, yep. All right, so your initial is 18,000, then 1 minus. How do you write 18% as a decimal? Very good. Do not put it in there as a percentage. Can somebody tell me why? Did we learn this? Because you don't what? Why can't you subtract? You can't do anything with a percentage. Somebody tell me why. It's not a value. It's not a number. 18% means 18 over 100. So to make it an actual integer or a value, a rational number, you have to write it as a fraction or decimal. Very good. So this would be the equation, right? Now, Grace, how long you think you'll have your first car? 4 years? Dang, girl. I had mine for 7. I think my first year teaching here, I still had that 99 Camry, and that thing was rough. Oh, it was very good. Like super good. I got hit by 2 deer and another car, and there were no damages. The old cars had like it's like the metal frame. Yeah, like it. The new cars suck. So I'm going to get back on topic. I had a 2015 RAV4. I got in a really bad accident in May, got a concussion, broke a rib, blah, blah, blah. That car crumbled because it had a plastic bumper. Other car hit me, crumbled, like totaled right then and there. So if you can, try to get one with a metal frame. But okay, anyways, she said 4 years. So how do we figure out what the value of the car is after 4 years? Put in 4 for the time. Beautiful. So we would just do 18,000 times, what's 1 minus 0.18? 0.82. Very good. Raised to the 4th. And if it's okay with y'all, I'm going to type that in. All right. 18,000 times 0.82 raised to the 4th. So after 4 years, she will hopefully be able to sell her car. Oh no, my calculator died. No. Good thing I got a whole drawer full. And you can do this in Desmos too, raised to the 4th. $8,138.19. Doesn't that suck? 4 years and you're out $10,000. My grandma always says life's a bee and then you die. And I'm like, oh my God, okay. She's very, what's a good word? Pessimistic. That's a great word. Very pessimistic. She literally says life's a bitch and then you die. And I'm like, oh my God, okay. Thanks for making me feel good about getting older. Yes. Great question, Maddox. Don't say what?
This makes more sense than when I learned it last
Oh, that's good. I love to teach this by letting y'all make up the examples because then you relate it to real life stuff. What do you mean what, Kevin? So Kevin, let's talk about it. Kevin's about to get a car. When he first buys the car, we sure are. So listen, when you first buy your car, Kevin, because your family's feeling very wealthy, it's, oh, thank you. It's $26,000. That's Kevin's initial cost of his car. 6 years later, Kevin's car is worth $12,000. Find me the rate. What do we do? Help me set it up. What would I write? Okay, the Y is 12,000 because that's how much it's worth 6 years later. What was the initial? Good. Look at Cody being a good listener. This is hard because I'm not like actually giving you a problem to write down. 1 minus R because we don't know the rate, and then I did tell you 6 years, so raised to the 6th. You can put 1 minus X. That's okay with me. Yep, because that's what you're solving for, okay? All right, so we want R by itself. We're trying to find the rate. So I'm going to cover this up for now. What do I move first? Divide by 26,000. Very good. So when I divide by 26,000, let's see, 12 over 26 would reduce to 6 over 13. Are you guys okay if I leave it as a fraction? Because 13 in the denominator means it's not going to be a nice decimal. So 6 over 13 equals 1 minus R to the 6th. What do you do next? Good. What kind of root? Not a square root. A 6th root of both sides to undo the 6, right? So you're not taking logs. There's no there's no need to do logs for this, okay? 6th root of each side. So I'm going to take the 6th root over here, and those will cancel. 6th root over here. So what we have is the 6th root of 6 over 13 equals 1 minus R. Keep in mind, what are we trying to find? The R. So what do you move next? How do you move a positive 1? Okay, subtract 1 to the other side. So I've got the 6th root of 6/13 minus 1 equals negative R, right? Because it said minus R. So then how do you make the R positive? Divide by -1 or just move the negative? Yeah, I'm going to divide by -1. So if you put this in the calculator, do y'all want me to use Desmos so you can practice, or are you fine if I do it in the calculator? Okay, that's fine. If you would like to check out a calculator, let me know. I have some on my cart you can check out. Second place is perfect. Yep. Let's see. I had a brain fart. I forgot what I was trying to do, Maddox. Yeah, or you can do 6/13 raised to the 1/6. Isn't that the same as the 6th root? That's what I normally do. Back in my day, we didn't have all those fancy buttons. All right, I'm getting 0.12.
So it's decaying by 12%.
So it is decaying by 12%. Very good. That's the rate. You said you got what? Did you round? I'm not trying to be funny. Did you round that? Yeah, that's why. Let me do it your way. Not answer. 6th root of 6/13. Did you put the -1 on the outside, or did you put it underneath the square root? No, 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 no. Don't change these signs. Literally type it in like this. 6th root of 6/13 -1 divided by -1. Okay. It should be 12%. So your rate here is 12%. So yes, Maddox, there will be some on the homework where you are working backwards to solve. Very good question. Good. Good. Is everybody okay with that? Yes, ma'am. Yeah. So let me tell y'all about this pre-cal exam. They give you a formula sheet. They give you all the formulas that are easy to remember on the sheet. It's very sad. My kids in the past have been like, can't you do something about that? I'm like, y'all think I'm a powerful woman. No, I cannot. Listen, they literally give you like easy formulas on the sheet, and you have to remember the hard ones. But it really shouldn't be that hard to remember. So are we good with growth and decay? Can you guys give me a real world example of something that usually grows in value in the real world? Okay, good. A house, if you upkeep it. Yes. But yes, your house, like my house, when I bought it, it was foreclosed. That's why I was able to buy it, because my husband was unemployed at the time and we had no money. So my house was foreclosed, and then after a year, we like redid everything. So now it's super nice. We'll make way more money off of it if we ever move. Okay. Money, if you invest it, like in a savings account, will grow. If you get a pay raise, normally that's linear because it goes up by a specific amount. Yeah, antiques. Usually antiques, the longer you have them, the value accrues, it grows. Yep, good. So we feel okay with growth and decay. If I give you a problem like this on the test, which you do have one, you can set it up. Beautiful. Yeah, bacteria growth, good. Like if you get sick, yep. We don't do half-life in, let me rephrase that. We do half-life in here. I don't make you memorize the formula because there's an easier way to do it. I will show you that tomorrow, okay? All right, next thing you need to recall. You can do it on the same page. I just ran out of room. Are your interest formulas. Formulas, there's two. The first one, let me do different colors because that was working for us, is your compound interest formula. And your second one is your continuous compounding formula. All right, are y'all okay for these if I continue just making up examples? Okay, great. Compound interest, I'm thinking this is the one y'all don't always remember. So your final amount, that's why it's A, it stands for amount. Your amount equals the principal, which was your initial value, times, and this one's different than the other ones just because you can change the number of times in a year that something is compounded, okay? Do we remember that? So it's just like growth though. I need you to understand that. It is just like growth. It shouldn't be hard to memorize. 1 plus, and then in growth, what would come next? 1 plus what? R. The only thing that changes is I can change the number of times it's compounded. So we're going to do R over N. But remember, I'm showing you where it comes from. It's just like growth. So I would need the N's to cancel, which is why you put another N up there, because growth is just P 1 plus R to the T. So you have an N in each spot to cancel out to make it look like growth. This is derived from the growth formula, okay? But yes, that is your formula. You will need to know that. This next one, hopefully we remember. This one is actually used more in the real world. A equals PE to the RT. A-PERT, that's what I call it. A-PERT. If you wrote A-P-E-R-T, that's what it would spell, A-PERT. This one is used more with bacteria, medicine, animal populations. The amount you end up with, so the final amount equals the principal, and it just uses E as its factor. Because I told you in the real world, E, environment, nature, when you're talking about like bacteria, sciencey things, it uses E as its base, raised to the rate times the time. All right, so can we do an example? I'll probably do one of each, and then I'll do one working backwards, and we'll be done, because I feel like we should be okay with this. Online people, are y'all okay with me just saying the situation and us setting it up together again?
Yeah.
Okay, let me know if you're not. I can actually write it. All right, we're on example 3. Who wants to buy a house? Okay, I saw Taryn first. Taryn is buying a house. We're listening, right? Testing your auditory skills. I said auditorial listening the other day in the meeting with your mom. She started laughing at me. I was like, English isn't my thing. All right, Taryn's buying a house. Okay. She purchases the house for $154,000. Is everybody with me? Okay. The house's value is increasing by a rate of 6% compounded semi-annually. Okay. Find the value of the house after 11 years. So I sure can. Hopefully I remember it. Taryn's buying a house. She bought it for $154,000. Its value is increasing at a rate of 6% a year, compounded semi-annually. Find the value after 11 years. So if we set up an equation, we're trying to find the value, right? The initial cost of the house, she bought it for $154,000. That's how much my house costs. No, you do not pay that much. You put down a down payment and then you pay it off for your entire life, basically. So $154,000, it's increasing. What did I say her rate was each year? 6%. So do y'all agree that's 0.06? Okay. Over, if it's compounded semi-annually, that's twice in a year. Semi-annually, semi-annual, it means the same thing as biannual. Semi means you break it up in halves, okay? So raised to the, we got to get rid of that 2 now. We're compounding it twice every 11 years. So it's compounded twice every 11 years. That's why you multiply right there. Once you get here, you can honestly put this straight in the calculator. Now, listen to me carefully because I don't want y'all putting it straight in the calculator because y'all don't know where to put parentheses and stuff. I would use Desmos because you don't need parentheses. Like it'll do the 0.06 over 2. Or I would do it this way. So just watch me. Tomorrow I'll have the calculators out. I just forgot today. So I'm going to do the inside first. So 0.06 divided by 2 should be, yep, I just wanted to make sure. So this will be 1 plus 0.03, right? Which is 1.03. Okay, so now watch. I'm going to do 154,000 times 1.03 raised to the, what's 2 times 11? 22. So after 11 years, her house's value, dang girl, you got a good house. After 11 years, her house's value is $295,000, 79 cents, or not 79, 79, and then 93 cents. Make sure you round right with your money. If the number behind the second place is 5 or bigger, it goes up. If it's smaller, it goes down. We remember how to do that? Okay, great. If we're talking about money, so yes. If it's not talking about money, if it's grams or something, then no. But if I tell you where to round, just do it to that spot. All right, example 4. Let's talk about the coronavirus. Why not? Since she is ruining all of our lives. Okay, when a person is initially infected with the coronavirus, there are 500 grams of bacteria. I don't know. I'm not a science person. I'm just making it up, okay? But I said when they're initially infected, there's 500 grams. Cool? All right. The rate that the bacteria increase is by 4%. How much bacteria will be in their body after 3 days? Let's do 3 hours, because why not? After 3 hours, how much bacteria will be in their body? Because bacteria grows quickly. If it is compounded continuously. So one more time. When a person is initially infected with COVID, they have 500 grams of bacteria in their body. That is growing or increasing at a rate of 4%. Find how much bacteria is in their body after 3 hours if the bacteria compounds continuously. Did you guys hear me say compound continuously? What formula are we automatically using? A per, beautiful. So we don't know how much bacteria is in their body. So A equals. But what was the initial amount? 500. E, what was the rate? Good. Colin got that. Good listening. And what was the time? 3 hours. These are even easier to type in the calculator. Okay? So are you guys okay if I type it in and you watch? Yes, ma'am. So when you are doing a PERT, because, okay, let me explain it better. In this one, time is always in years. If I give you months, listen very carefully. I hope you can put it together while I'm telling you this. If I give you months in the problem, you got to change that to years, okay? Because compound interest is all about how many times it's compounded in 1 year. Continuous compounding isn't in years, it's not in days, it's not in hours, it's in whatever they give you. So if we're talking about hours, we'll multiply the rate by the hours because it's going up by that rate each hour. If we're talking about days, it's going up by that rate each day. Does that make sense? So time is not a set thing in APER. It's whatever they give you. So that's why you're not doing 1 plus or 1 minus, okay? All right, so this, if we type it in, 500 e raised to the 0.04 times 3. So after 3 hours, the bacteria have grown to 563.75. What if I told you to round it to the nearest bacteria? Because technically you can't have a quarter of a bacteria. 564. 4. Bacteria don't grow by decimals. Like if there's 563.75, there's a 564th one. Okay? So this is approximately 564 grams of COVID germs. Ew. I don't think it grows as bad as they're saying. But I don't think they know, so I think they're just trying to keep us all safe. Can't get mad at that. I like my life. I would like to live for a long time.
What do you think in the natural?
In Desmos, there's literally a E button. You can also just put E in Desmos and it'll know what you're talking about. But it's right here above the natural log. Yep. So you see how it says E to the X in blue? Just hit second ln. All right, last example. Let's do one where we got to work backwards. I'm going to do another of this top one because I feel like this is the one we need more practice with. Sound good? Okay. I'm going to write some stuff down. Write it down because I won't remember it either. We'll use Miss Pool's example. When did I buy my house? 2019. In 2019, Miss Pool purchased a house for $154,000. In, I don't know, let's say 2025. In 2025, I sold the house, or I will sell the house, for $220,000. Find the rate if it was compounded quarterly. I will zoom this in, Cody. I'm sorry. That's very small for you and Kevin and Colin. Yes. It does say quarterly, yes. Sorry, my handwriting got kind of smudged. Mine's terrible too. All right, I bought a house in 2019 for $154,000. In 2025, I'm going to sell it for $220,000. Find the rate if compounded quarterly. Did it say continuous anywhere? Don't use APER. It says I'm compounding it quarterly, which means how many times in a year? 4. Beautiful. So let's try to set up the equation. People at home, are y'all still good? I'm hoping they're good. All right. I sold it. My final amount that I sold it for was $220,000. My initial amount was $154,000. We don't know the rate. Does everybody agree with that? So I'm going to put R. But how many times am I compounding it? 4. And then good. Colin, how many years has it been? Huh? 6. Good. Don't let them trick you with that. There's one like this on the test. 6 years. It's been 6 because they gave me 2019, 2025. 6 years. All right. So I am going to go a little quickly. Just stay with me. If you have a question, you can hang back. I'll write you a pass to your next class. Unless your teacher isn't chill with that, and you should know that. So don't get me in trouble. You would divide the 154, right? This is where all the children say yes?
Yeah.
Great. Yes, Miss Poole. Beautiful. All right. $220 divided by 154 is a yucky number. I'm getting 10 over 7 is what that reduces to.
Make the calculator turn into a
You hit math, don't pack up. Math, enter,
That's what
enter.
it was.
Yep. But Desmos will do it for you as well. All right, 10 over 7 equals 1 plus, oh my God, I forgot the 1. R over 4. I will finish this and post it on Canvas. Does that sound good? To the 24th. So now how would you undo raising this to the 24th power? Sydney, Drake, Mariana, Ross, Kayla, and somebody. How do you undo raising something to the 24th? Yeah, take the 24th root. So the 24th root of 10 over 7 equals, and that goes away now, 1 plus R over 4. So what do I do next?
Minus the 1.
Good, subtract the 1, beautiful. 24th root of 10 over 7 minus 1 equals R over 4. And then what? What would we do?
Multiply the 4.
Yeah, multiply both sides by 4, and this whole thing gets multiplied by 4. So you can type in your calculator or Desmos 4 parentheses 24th root of 10 over 7 minus 1. And I have my calculator right here, so I'll let y'all know what that is. Minus 1 times 4. I'm getting 0.059, which would round to 0.06, right? So R is approximately 0.06 or 6%. Are y'all okay with that one?
If we leave it as 0.06, we use to count.
Yes, that's right. You can put 0.06, you can leave it in decimal form, or you can change it to a percent. Okay? All right, so let me look at the homework. Let me see which one would be a good one to do. This is a good one right here. All right, so we're gonna do number 3 off the homework. So you guys can just put it in your notebooks, or if you have the worksheet, you can do it up there.
Miss Poole,
Yeah,
what is our home? What are our homework?
it's on Canvas. I gave you one in your packet last week though, but it's this worksheet, exponential functions, compound interest, growth, and decay, and you're just doing 1 through 7.
Okay, thank you.
Uh-huh. All right, so number 3, how many years will it take for an initial investment to grow to $25,000? Assume a rate of 6% compounded quarterly. So if it says compounded quarterly, that should tell you you're using this formula. Are we okay with that? Yes, no?
Yes.
Okay, y'all gotta talk to me. It's just me and y'all now. All right, so the initial amount was 10,000. Do we agree? And after it grows, it's gonna end up at 25,000. So what do I write? How do I start it?
25,000 equals 10,000
Good.
parentheses
And plus, yep. What's the rate?
0.06
Good.
over 4
Over 4, why, Ross? Because it's compounded.
quarterly.
Good. And then raised to the 4. And then what are we trying to find?
The time.
The time. So we don't know t, we're trying to find t. So that's what's different about this one. Are y'all okay there?
Yes.
Okay. So now, same thing. First thing you would do to be able to get to this part is divide the 10,000. So I'm going to divide 10,000 to the other side. And that should reduce to 5 over 2. If somebody wants to check me, that would be great. And then, are y'all okay if I go ahead and simplify this too? Just to make it easier.
Yeah.
So 0.06 divided by 4 is 0.015. So then plus 1. So this is going to be 1.015 raised to the 4t. I just simplified what was in parentheses. All right, so this is where it gets different because we need to be able to get to this t, and the t is in the exponent. So does anybody remember from math 3 or from my class, because we've been doing it, what I can do to be able to bring that exponent down?
Move it to the front.
But you can't do that yet. There's something you got to do first. That's a log property. Do y'all see any logs? Y'all, I'm not trying to trick you. Does this say log anywhere?
No.
No. But Ross said if it does say log, we could bring down the 4t, right? So this is where you would take the log of both sides. So log of 5/2 equals 4t. I can bring it down now because I'm doing log of 1.015. So if you take the log of both sides, Ross is right, then you can bring the exponent down and be able to get to the time. Are we okay with that?
Yes.
Okay, so now to solve for t, you're just going to divide 4 log of 1.015. 4 log 1.015. So I'm going to divide that on both sides. So then I'm going to do that in the calculator with y'all. So we've got the log of 5/2 divided by parentheses, because I want to divide by the whole bottom. So I'm going to use parentheses. 4 log of 1.015. And I'm going to close the log argument and close the denominator parentheses. So for the time, I'm getting 15.39 years. And this is one of the harder ones up here. I think there's only one more like